Hello and welcome to my Blender animation mini class. I'm Harry, a seasoned 3D artist with over a decade of professional experience, and the privilege of being recognized as a top teacher on Skillshare, specializing in Blender tutorials. Hey there, this is Harry from the future. The class you're about to watch is taken directly from Skillshare, where I've been fortunate enough to be recognized as a top teacher with 4 different staff pick classes and well over a dozen site features. I've uploaded this entire class to YouTube so you can all watch it completely for free. This class will be a little bit different though than your typical YouTube tutorial. I'll be going over each step at a comfortable pace, so beginners shouldn't feel rushed while following along. Feel free to speed up the video though if you're already comfortable in Blender, or you don't mind a quicker pace. If you like what you're seeing, please consider subscribing, liking the video, and sharing it with your friends. It really helps me out and allows me to bring more classes to YouTube so you can all watch them for free. Lastly, before we jump into class, I've included a link to a free month of premium Skillshare membership in the description and comments below. Get access to all of my classes and thousands more completely free for a full month. Okay, let's get back to class. In this class, we'll learn how to create a futuristic looking animatable ferrofluid material. You'll have full control over the spikes emerging from the liquid by animating the placement of an invisible magnet object. If you're unfamiliar with ferrofluid, it's essentially a metallic liquid that responds to magnets in really interesting ways, such as creating these moving spikes. My Blender classes are well regarded for their clarity and ease, thanks to a step-by-step approach that's perfect for beginners. While this is a shorter mini class, you can still expect thorough explanations that anyone can follow regardless of their experience. Please note that Blender 4.3 or later is required to follow along with this class. You can download the latest version of Blender completely free from their website. By the end of this class, you'll be amazed at how easy it is to create a realistic and animatable ferrofluid material. So, if you're ready, I invite you to join me in class. Let's jump into our first lesson together. In this lesson, we'll begin the class by setting up our working file. Let's begin. Our goal for this lesson is to make sure that we have everything we need set up for creating the material in the next lesson. This will include some simple render settings, output settings, an object to place the material on, a camera, and some lights. Before we begin, make sure you open a new Blender file and then select the general file type found here on the left. You also want to make sure that you're using Blender version 4.3 or later. This material is really only possible with the use of the updated Eevee displacement settings found in Blender version 4.2. I'll be using Blender version 4.3 for this class, so if you want to ensure everything works like it does in the video, I'd highly recommend using version 4.3 or later. With your file open, let's start with the render and output settings. We'll find the render settings over here on the right side in this tab here. This tab should be open by default, but if not, simply click on this icon here and it'll switch to this tab. First up, you want to make sure that your render engine is set to Eevee, which is found here. Next, we're going to scroll down here until we find the setting called Ray Tracing, and we're going to check this box on. The setting is really important as it makes sure our reflections on our material look a little bit more realistic. We won't need to adjust any of the settings found inside Ray Tracing, as the defaults will work fine for our project. Now let's scroll all the way down to the very bottom, then we're going to twirl open Color Management, and then scroll down a little further so we can see these settings. The only thing that will be changing in this setting, assuming it's not already set by default, is the View Transform found here. Right now mine is set to Filmic, and that's what I want to leave it on. If yours isn't set to Filmic, make sure you switch it to Filmic from this list. This setting just changes how Blender handles brightness and color within our image, and for our purposes, Filmic works best. Now let's adjust our output settings, and we can find those here at the top, and it's the tab just below the render settings. It looks like a little printer printing out a photograph. We're going to scroll all the way up to the very top of this list, and we'll start by switching the X resolution found here to 1080 and then hitting enter. That way it matches the Y just below, which means we'll be creating a square image. And then lastly, we'll go down here to where it says frame rate, and we're going to switch from 24 FPS to 30 instead. This will make our animation just a little bit smoother, and it'll make some of the math a bit easier when we get to animating. With that last setting changed, we're ready to start editing the viewport. So we're going to start by selecting this default cube, and then hitting the delete key to remove it. Now we can hit Shift and A at the same time to bring up our Add menu, then go to Mesh, and then we're going to choose Icosphere, and then click that. And then before we do any other clicks, we're going to go down here to the bottom left, twirl open this option box, and then we need to change some of these settings. So first we're going to set our subdivision from 2 all the way up to 8. This will make the sphere much smoother. This additional geometry is going to be important for our displacement later on. Next, we're going to go down here to the radius, and we're going to make it a bit smaller. We'll set this to 0.85 and then hit enter. So it's 0.85 meters. It's important that we have a pretty high subdivision amount, as that's what controls how smooth the spikes coming from our material will be. Lower values will create a much more jagged spike with less definition. This will somewhat ruin the liquid illusion that we're trying to create. With these settings changed, now we can right click on top of our sphere, and then we're going to choose Shade Smooth. We want to make sure that the liquid surface looks as smooth and free of faceting as possible. With the object created, we can now position our camera. Our first step is to look through the camera. And we can do that easily by going over here on the top right and then clicking on this camera icon. This will jump us into our camera's view. And now while hovering over this middle viewport, we're going to hit N on our keyboard to bring up the side menu. And then we can go over here to the item tab found at the top. Now on the top right outliner list, we're going to select the camera, and then we'll go over here to the side menu, and we're going to change each of these values into an exact number that I give you. That way our cameras are set up in the exact same position. It'll just make it a little bit easier to follow along with the video. So starting from the top for the X location, we're going to type in 2.85. The Y location, we'll type in -1.85. And then for the Z, we'll type in 0.9. And we're not quite done yet because we have to adjust the rotation. So for the X rotation, we'll type in 76. We'll leave the Y rotation set to 0. And then the Z, we'll type in 57. These are the exact values that I'll be using for the position and angle of our camera in this class. Feel free to adjust the view of your camera as you'd like, but if you want it to be easy as possible to follow along, I'd recommend you stick with these values at least until you create your own version after we finish these lessons. With our camera placed, we're getting close to the end of this lesson. Let's get our interface customized a little bit before we move on to the next step. To customize this viewport layout, we're going to go over here to the top left corner with our mouse. We're going to wait until it turns into this little plus sign found here at the top left. And then we're going to click and drag, and then drag it over here to the right side. And now we can see we're dragging out a border between the two. We're going to drag it about halfway. It doesn't need to be perfect, just roughly halfway. And then we're going to let go of our click and drag to place this two different viewports. Now while hovering over both of these different viewports, we're just going to go left or right. So on the left side, we're going to hit N to hide this side menu. And then the same thing, we're just going to hover on the right side, hit N to hide the side menu. Now let's change this left viewport so that it's not just a copy of the right. We're going to switch this left side to the shader editor. We can do that by going up here to the top left. We're going to click on this drop-down menu found here, and then we'll go down this list and choose shader editor. And then again, while hovering over this left side, we can hit N to hide this side menu. In the next lesson, this is the viewport that we'll be creating our Ferrofluid material in. For now, however, we'll be using the shader editor to add an HDRI to our scene so we have some lighting. If you're unfamiliar with the concept of an HDRI, they're essentially just images with a lot of hidden data stored inside them that allows you to generate realistic lighting and reflections from them. And to add this HDRI lighting, we'll be using the shader editor. That's because the HDRI is an image and not a traditional light. At the very top left here, we're going to see a drop-down that says Object. We're going to click on this drop-down and instead choose World. And before we begin, to make our lives just a bit easier, we're going to enable a really useful built-in add-on called Node Wrangler. To enable this add-on, we'll go to Edit, then down to Preferences, then we'll go over here to where it says Add-ons, and then up here in the search bar, make sure you don't have Enabled Only checked on, so make sure this is checked off. You'll type in the word Node, N-O-D-E, and then you should see Node Wrangler pop up. Now yours might be unchecked. If that's the case, just check it on so that it looks like mine. Once you have Node Wrangler turned on, we can just close this option box. There's no need to restart Blender or anything, it's ready to go right away. This Node Wrangler add-on does a ton of useful things, but the main thing we'll be using is the ability to make nodes automatically with just a single click. If this is your first time diving into the shader editor, you shouldn't have any issues following along in this class. However, if you'd like a much deeper dive into all aspects of material creation, I'd recommend my Magic of Materials class on Skillshare. This multi-hour class explains everything you need to know about material creation in Blender from a complete beginner's perspective. As a quick explainer of how to navigate, You can move around in the shader editor using your mouse wheel. So if we scroll up and down, that'll allow us to zoom in and out. And if we click in the middle mouse button, it allows us to slide the view around so we can pan left or right or up and down. Each of these squares that we're seeing here on the screen are called nodes, and we connect these nodes together with these wires by attaching them from socket to socket. These small dots here are called sockets. These nodes pass their attributes from left to the right. So this background node is transferring all of its different properties to this world output node. By chaining multiple nodes together, we can make complex materials by combining simple effects. Now we can left click on this background node here to select it, and then we're going to hit Control and T at the same time on our keyboard to create 3 brand new nodes. We can zoom out here to see the nodes that they created, and then click in our middle mouse button to pan to the side. Without Node Wrangler installed, you could still manually create each of these 3 nodes by hitting Shift and A, then going to Search, and then typing in each of these names. However, the Node Wrangler add-on just lets us do all this really easily with a simple click. Now let's get the HDRI added to our scene so we have some new lighting. Let's zoom in here to this orange node called Environment Texture. Then we'll go over here and click the Open button. The HDRI that we'll be using for this class is actually already downloaded to your computer. You just don't know it yet. This HDRI is installed along with Blender when you download it. So all we need to do is find it on your computer and link it to our scene. On a Windows computer, you can follow along to this path shown on screen. On a Mac computer, you'll need to find the Blender Foundation folder in the Apps folder. Once you've found the Blender Foundation folder, then you can go into the version of Blender that you're using, in my case, Blender 4.3. Next, we'll go into 4.3, then Data Files found here at the top, Studio Lights, World, and then here is where we find all these HDRIs. The HDRI that we'll be using for this class is called interior.exr. So we can select this and then hit Open Image. With our HDRI loaded, we've successfully added light to our scene, but we can't see it in our viewport just yet. We need to switch our right viewport to the rendered mode so that we can see our new HDRI. We're going to do this up here at the top right, and we actually need to click in our middle mouse button on this option bar. That way it lets us drag it to the left, because right now these buttons are hidden that we need to see. So we're going to drag it all the way to the left until it stops. And then over here on the far right, we're going to click this far right button. You might notice that your computer freezes for just a second as it loads the image. That's completely fine, just wait for it to load. And now down here, we can actually see our lighting as well as the background image that we just loaded up. This HDRI makes it look like our sphere is floating in the middle of a hotel room, which has some pretty nice lighting. We can improve the lighting though by rotating the HDRI on the Z-axis. This will spin the room so that the large window is behind our object instead of directly in front of it. We'll be spinning this image over here on the left side by zooming out a little bit, and then panning over here to the mapping node. And all we'll be doing is going down here to the Z rotation and typing in 180 and then hitting enter. So we can see here it's rotated the image completely around, so we're seeing the exact opposite side. If you wanted to pick a different direction, you could just slide this back and forth until you find a view you like. But for this class, I'll be using 180. This large curtained window in the background is nice and bright and also isn't too distracting from the actual orb in the center. Over here in our right viewport, if you'd like to, you can use your mouse wheel and also click in the middle mouse button to zoom in a bit so you can see better view. With our HDRI finalized, let's go back over here to the shader editor and then swap from the World tab back to the Object tab. And now the last thing we need to do for this lesson is to save our file so it's ready for the next lesson. To do this, we can go up here to File and then Save, and then just navigate to somewhere on your computer that you'd like to save your Blender file. And then lastly, we'll go down here and then change the name of the file. I'll call mine Ferrofluid material _01. And then when I'm done with my name, I just click Save Blender File. And that's it. We're ready to move on with the rest of the class. In the next lesson, we'll create the Ferrofluid material. I'll see you there. In this lesson, we'll create the Ferrofluid material. We've got a good bit of work to do on this material, so let's jump right in. First, make sure your right viewport is set to the rendered view like mine is here. To set this viewport to the rendered view, go up to this top option bar, click in your middle mouse button to pan it all the way over here to the left, and then make sure that this button here is clicked. This is important as we actually need to see our material as we work on it, rather than the plain gray of the default solid view. Now in the right viewport, go ahead and click on your orb here to select it. With it selected, go over here to the left side, and then we're going to click on this new button at the top of the shader editor to create a new material. Now let's click in our middle mouse button up here to pan this view to the left a little bit. And then right here where it says material, we're going to name our material. So we're going to type in Ferrofluid. Our first step is to make the base material look a little bit more like Ferrofluid. This won't include any of the spikes just yet, but we need to make a convincing base material to animate first. So now let's use our mouse wheel to zoom in here. We're going to zoom in so that we can see this entire green node here. Now let's select this white box next to base color, and that'll bring up a color picker. We have two main ways of using this color picker. We can either click and drag here to just pick a color on this wheel, which is nice for just choosing a color that you want, and you don't need to be too exact with it. So you can click and drag this little circle, place it where you want, and then on the right side, you can click and drag this box to either make it darker or lighter. While this is an easy method of picking colors, it's not super useful when you're trying to get an exact color. If you know the exact color that you want, the sliders at the bottom here are actually a bit more useful. So for this tutorial, we're going to use these sliders. So first we can click and drag on this slider here at the top for the hue, and just drag it all the way to the left so that it's set to 0. Next, we'll do the same thing for the saturation. We're going to drag it all the way to the left so it's also set to 0. And then lastly, we're going to click on this value slider here, the third one down, and we'll type in 0.025 and then hit enter. This will make this base color almost entirely black. It's a really, really dark gray. This should work great for our Ferrofluid material. Now we can hover our mouse over here to the left so that it hides the color picker. Our next change is for the metallic slider found here. We're just going to click and drag on this metallic slider and drag it all the way over here to the right. This will make the material fully metallic so that it reflects light like the Ferrofluid would. It also makes the material have much deeper shadows and brighter highlights. And then our last change here, we'll be changing the roughness value. We're going to click on this roughness and then type in 0.05 and then hit enter. This makes the reflections on the orb significantly sharper and a lot more like liquid. A lower roughness value, like 0.05, will make these reflections a lot sharper and more liquid-like, whereas a higher roughness value will make them more diffuse and blurry. In our case, we want it to be more like liquid, so we'll set it back to 0.05. Now let's add a subtle waviness to the surface to make it look more like liquid. We're going to need 2 new nodes for this effect. So first, let's zoom out so we have a little bit more room over here on the left side. And then we're going to hit Shift and A at the same time to bring up our add menu. And then at the top for the search bar, we're going to type in bump, B-U-M-P, place that here just by clicking. And then we'll hit Shift and A again, go to search, click on this, and then type in noise, N-O-I-S-E, and we're going to choose noise texture, not white noise texture. We want the top one. So we'll choose noise texture and then place it over here to the left. Now let's zoom into these new nodes that we just added so we can see them a bit better. Now let's connect this factor socket found here at the top of the noise texture by clicking and dragging on this dot down here to the height socket found on the bump node. And then lastly, we're going to drag from this normal socket here on the bump node over here to the matching normal socket found here on this principled BSDF. And now we can see the results here of these new nodes added to this node. It's creating a wavy surface on the surface of the orb. However, right now it's pretty strong and the waves aren't quite the right size. So let's fix that. First, we'll go over here to the noise texture. And the only thing we're going to change over here is changing the scale. We're going to set it from 5 down to 1 instead. So we'll just type in 1 and hit enter. This lower value for the scale has actually made the noise pattern much larger. Larger numbers for your scale will actually make a smaller pattern, whereas smaller numbers like 1 will make a larger pattern. Now we can go over here to the bump, and we're going to change the strength slider, because right now it's really strong. We're going to lower this down to a much smaller value. We're going to type in 0.025 and then hit enter. We're setting the strength to a really low value, as we want the waviness to be as subtle as possible when we animate it later in class. If it's too strong when we animate it, it'll be really distracting. So So even though it looks like it's not even visible here, we can tell that it is doing a little bit of waviness along the edges, and when this waviness starts moving, it'll be a lot more noticeable. Next up, we'll be covering the sphere in spikes. Adding spikes to this whole sphere is the first important step before we limit them to only the areas nearest the magnet object that we'll create. Let's start by creating a few nodes and then we'll connect them together. So over here on our left side, we're going to zoom out a little bit with our mouse wheel, then pan down. Now we can hit Shift A, go to search, then we'll type in displacement, D-I-S, and then we can see it here at the top, displacement. We'll just click and place that here. Again, Shift and A, search, and then we'll type in color, and we're going to choose color ramp, the second option. Click that, and then place it to the left. And then one last node, we'll hit Shift and A, search, and we'll type in Voronoi, which is spelled V-O-R, and that should be enough to find it here at the top, Voronoi texture. And then we'll place that here to the left. Now let's zoom in down here on these new nodes so we can see them better as we connect them. We'll drag from the distance socket here down to the factor socket found here at the bottom. Now we'll drag from the color socket found here to the height socket on the displacement. And then lastly, we're going to zoom out a little bit, pan over, and then we're going to click and drag this material output from the top here. So we're just moving the whole node. We're going to drag it down a little bit. And now we can zoom in a little bit more and then drag from displacement here to displacement over here. Now before we make any adjustments to these new 3 nodes that we added, we do need to enable a new setting. To do this, we're going to go over here to the right side. And we're going to click on this material properties found here at the very bottom. It's this red circle with the checker pattern on it. Now we'll scroll down this list until we find this area called settings, and make sure it's twirled open if it's not already. So you just click on this and it'll twirl open the options. And then the setting we need to change is found underneath the surface options found here. So make sure that's twirled open. And then we're going to go to displacement, and right now it's set to bump only. We're going to click on this drop down and then choose displacement and bump. This setting allows Blender to actually displace the geometry of the sphere rather than faking it using only the bump. This is integral for the Ferrofluid animation we'll be making. We can now see the results of the new nodes that we just added. The displacement node allows the previous 2 nodes in the system here to move the surface of the sphere and give it spikes. Before we move on, let's go up here to the top right. We're going to click on this button here to hide the viewport overlays. And we'll see when we click this, it hides this annoying orange circle that we see here. Kind of ruins the illusion, so we're just going to click this button to hide it for now. Now let's start making adjustments to these nodes. We're going to start with this displacement node. We're going to go over here to where it says mid-level. We're just going to click on this and then type in 0 and hit enter. This will allow the spikes to protrude further from the sphere. Next, we're going to go to the color ramp found here in the middle. We can zoom in a little bit for this one. And our first step is to click here on this little drop down. We're going to choose flip color ramp. So it's going to flip this gradient. Instead of being black to white, now it's white to black. And we can see that's made a difference over here on the spikes. By flipping the colors on this color ramp node, we're inverting the black and white image produced by this Voronoi texture and essentially turning it inside out. This has the effect of converting the crater style spikes that we had before into these more pointy mountain styles that we're seeing here. This looks a lot more like Ferrofluid, so it works great for our purposes. Now let's begin adjusting the positions of these colors on the gradient. So we want to move this black slider to the left slightly. So we can either select it by clicking on this little triangle here at the top of it, and then we can move it this way. Or if you want, you can use these buttons down here. So if it's set to 1, it's going to choose the far right slider. And if you click this little arrow, now it'll choose the far left slider. So it's 0 for here and 1 for here. So we're going to set it to 1 so that it's selecting the black slider. And then this position can also be controlled down here as well. So for us, we're going to set this position to 0.85 and then hit enter. This is going to add a little bit more black to the texture. And also over here, if we look at our spikes, it's making them a little bit sharper. So as we add more black, we're making the spikes a little bit narrower at the bottom. Now let's move over here to the left and adjust the Voronoi texture. Let's start from the top and then we'll just go down the list and change each value. So our scale, we're going to set to 10. This will make the spikes tinier. We're going to drag the roughness all the way to the left so that it's set to 0. The linearity below, we're going to set that also to 0. And then lastly is the randomness found down here. So I drag this over to the left a little bit, you can see the full names. So this randomness, we're going to set this to 0.1 instead. The two most important settings that we changed here are the scale and the randomness. The scale is pretty obvious, as it changes the size of the Voronoi pattern. This will make the spikes smaller or larger depending on the value. So if we just drag this left and right, we can see higher numbers make tinier spikes, and lower numbers make larger spikes. So we're going to leave ours set to 10. The randomness value down here changes the chaotic and random pattern of the Voronoi texture into orderly rows of spikes. So a lower value here will make them more orderly, and a higher value will make them more random. Because our spikes right now are so strong, it's a little bit hard to tell the difference between the randomness values, but we're going to leave ours set to 0.1, which makes them a little bit more orderly, not entirely in rows, but mostly in rows. In real life, the spikes of ferrofluid align themselves in orderly rows of concentric circles. This is thanks to the magnetism pulling their liquid into rigid patterns. Up to this point, these spikes have been so strong on the surface of the sphere that they're basically breaking it apart. This is why some of these spikes can sometimes appear a little bit broken, or speckled, or see-through. To fix this broken surface, we need to limit the effect of the spikes to only specific areas. We'll be limiting the effect by creating a black and white circle across the surface that is tied to an invisible magnet object. The closer the magnet is to the surface, the stronger the spikes will be. Anywhere not close to this magnet object will have no spikes at all. Let's start this process by creating all the nodes that we'll need for this effect. So over here on our shader editor, we're going to zoom out a bit and then pan here to the side. Now we need to make some room over here. So we're going to pan over a little bit further, click and drag over top of this color ramp and the Voronoi node. We're going to drag them over to the left to create some space here between them. Now let's hit Shift and A to bring up our add menu. We'll go to search. We'll start with typing in mix, M-I-X, and choosing mix color. We can drag that over here and place it just below this line for now. Now we'll hit Shift and A again, search. We'll search for color ramp again. So we'll type in color and then choose color ramp. Place this over here just below the other color ramp. And then lastly, Shift and A, search. This time we'll type in gradient. So G-R-A should be enough to have it show up. We'll choose gradient texture. Click that and then place it over here to the left. Now we can begin attaching these nodes and adding the remaining support nodes. First thing we'll do is we're going to click on this mix node here, and we're going to drag it on top of this line where we made this space. And we'll see as we drag it over top, it highlights. So once it's highlighted, we can just let go of the drag and it'll automatically connect it for us. Now let's zoom in a bit down here, and we're going to drag from the color socket here on the color ramp up here to the B socket on this mix color node. Now we can drag from the factor socket here on the gradient texture down here to the factor socket on the color ramp. Now we can zoom out here on the shader editor. We're going to select this gradient texture node found here at the very bottom, and then we're going to hit Control and T to use Node Wrangler to create two new nodes for us. And this will create the mapping and the texture coordinate node. We're going to drag select over these two new nodes that we have, and then we're going to move them up here. We kind of want them floating out here in space between the top and the bottom of this texture. Node Wrangler luckily already connected the vector socket from here to the gradient node. However, we do need to connect it also to this texture node up here. So we're just going to zoom in a little bit. We're going to drag from this vector socket here over to the vector socket found here on the noise texture here at the top. This has told Blender to use this node to power the vector for both of these nodes. So whatever this node does is being applied to both the gradient texture as well as the noise texture. In really basic terms, these two new nodes that we added, both the texture coordinate and the mapping node found here, are basically just telling Blender how to place these spikes along the surface of this orb. There are a lot of different modes here, and we'll get into them in just a minute, but that's basically what these nodes are doing. Let's go through each of these new nodes that we just added and get their values set up before we add the new magnet object that will control many of the aspects. So we're going to start by zooming out and going over here to this yellow mix node. We're going to zoom in here. We're going to click this drop down here where it says mix and then set it instead to multiply. This will make sure that only the black portions of the gradient texture that we added overlay the underlying Voronoi texture. This is an important part of making sure that the magnet only affects the areas we want. Now we'll go down here to the factor. We're going to drag it all the way over here to the right side and set it to 1. This will make sure that the black parts of the gradient are completely opaque, meaning it will fully suppress the spikes in those areas. Now let's zoom out. We're going to go over here to the gradient texture. And right now it's set to linear. We're going to set this instead to spherical, found here at the bottom. This changes the linear straight line gradient into a circular gradient. This will work perfect for replicating the pull of a magnet on the surface of the sphere. We can already see an example of that here. So now we can see the spikes are only on this bottom side, and it's completely smooth over here on the right side. And then lastly, we're going to go over here to the color ramp. We can zoom in a bit. And now we can select the far left black slider by either setting this slider here to 0 or just clicking on this little triangle found here above this square. We're going to set this position to 0.1, hit enter to move it up just a little bit, adding more black to this gradient. And now we can select this far right slider by either clicking on this triangle or setting it to 1. And then for the position, we're going to type in 0.595 and then hit enter. This has pulled this slider here over to the left, making more bright white in this texture. Essentially all this has done is increase the contrast of this gradient map. And our last step for this color ramp is to change how Blender is handling this gradient. By default, it's set to linear. But if we click on this dropdown, we see all these different options. The one that we want to use is called ease. So first, let's take a look here at the edge of this spike. We can see a really harsh line here where the spikes start and they stop. If we switch it to ease instead, we'll see it as it loads here, that this transition here is a lot smoother. It's more eased into it. So linear is a bit more harsh than ease. Ease has a bit of a blur here between the two, smoothing this transition out and just making it look more natural. Our last step is to create the invisible magnet that will control where the sphere gradient will be placed on the surface of this orb. The placement of the gradient is what reveals the spikes on our orb. So let's zoom out here on the left side. And we're going to be focusing over here on this texture coordinates and mapping node. The one on the far left that's connected to both of these. So we'll zoom in here. Now let's change the mode that this texture coordinate is using. Right now it's set to generated. We're going to instead switch this to object by clicking and dragging from here and then dragging it to vector. This object mode here is simply another option for placing these textures on the surface of the orb, but it allows us to add an object, such as the invisible magnet, to control the placement in real time rather than inside the shader editor. This will be really useful for animation later on. So first we'll need to create our magnet object. So over here in our right viewport, we're going to hit Shift and A to bring up our add menu. Then we'll go down here to where it says empty. We're going to choose empty sphere down here at the bottom. Before we click or do anything else, we're going to go down here and change the radius of this sphere. We're going to set it to 0.88 and then hit enter. 0.88 meters is roughly the size of the influence of the gradient texture that we created. So setting the size of the sphere to the same size makes visualizing the influence of this magnet a bit easier. Before we move on, we do need to re-enable this viewport overlay found here at the top. So we'll click this, and now we can actually see this empty object that we added, and that's this orange object here. Since this empty object isn't really visible for anything in terms of rendering, it's more or less just a utility object, it's hidden when you hide the viewport overlays. Now let's add this new empty object to the texture coordinate node. So first we'll need to select on this Ferrofluid orb again, that way we can see our texture over here on the left. And then on the far left side, this texture coordinate node, we're going to go down here to where it says object, click this eyedropper icon found here at the bottom right, and then we'll go over here and we're going to click on this empty object in the top right list. That will apply this empty object to this field. With this empty object added to the texture coordinate node, we're ready to check out the results. Let's select this empty object either by clicking it in the viewport or going over here and selecting it from the list. Now we can hover our mouse over here in the right viewport. We're going to hit G on our keyboard to grab this and then begin moving it. So now we can see as we move this object around, we can actually control exactly where these spikes appear. We can make them weaker by moving the orb either further away, or we can make them stronger by moving the orb closer. So we can see as we move this closer, the spikes get stronger. However, you will notice that there is a point at which once you move it so far, the tips of the spikes start breaking again, so you do have to be careful how far you move this orb. There's basically a maximum that these spikes can go before they start breaking. So we'll have to keep that in mind when we're animating. We'll also notice that by moving this around, again using the G key, we can see that the subtle wave that we added to just the smooth surface of the ball, so even without any spikes, we can see just by moving this back and forth that we're controlling that as well. And that's because we connected this texture coordinate node to both the noise texture as well as the Voronoi texture. So the Voronoi is the spikes, and the noise texture is that subtle ripple. So by connecting that spherical gradient to the position of this empty, we've essentially made an invisible magnet to affect our ferrofluid with. At this point, we're ready to move on to animating our material by moving around this empty magnet object. In the next lesson, we'll animate the invisible magnet object to make our ferrofluid react. I'll see you there. In this lesson, we'll animate the invisible magnet object to make our ferrofluid material react. Let's begin. Before we begin our animation, let's get our file set up and ready. We'll be working in the layout workspace again, just like the last few lessons. However, we'll want to switch the left shader editor back to the 3D viewport. We can do that by going up here to this option bar, clicking in our middle mouse button, and then panning it over to the right. Now we'll go over here to this left drop-down menu, and then choose 3D viewport. On our right viewport, we're going to go over here and turn off the viewport overlays to clean up the view a little bit. If you're unable to see these far right buttons, again, just click in your middle mouse button to pan this bar all the way over so you can see these buttons. So we'll click this viewport overlays to hide the overlays. And then lastly, we'll switch it back to the rendered view if you're not there already, which is this far right button. So make sure that this one is clicked. We'll be doing the bulk of our animating in the left viewport over here, as it's a bit easier to navigate without being bound to the view of the camera. We'll just be using the right viewport to see what the final result for the animation would look like. And then the last thing we need to do is make sure that we can actually see our timeline down here at the bottom. You may or may not be able to see yours. However, in my case, it's actually collapsed a little bit. So I'm going to click on this little border here above this timeline and pull it up just so I can actually see the timeline below. Before it was so small I couldn't actually see the timeline below it. Now let's determine how long our animation is going to be. I think 6 seconds should be long enough to show the animation we want to create, so let's start there. We know that we set our file to 30 frames per second in one of the first lessons for this class. So all we need to do is multiply 30 frames per second by 6 seconds. This means that our animation should be 180 frames long. To change the length of the animation, we can go over here to the bottom right where it says end. We're going to type in 180, so 180, and then hit enter. And we'll see down here that it's actually shortened the length of the animation. We can center this timeline a little bit better by hovering our mouse over top of this timeline and then hitting the home key on our keyboard. You can find the home key above the arrow keys on the right side of your keyboard. This will zoom the timeline in so that it fills the entire space. And at any point, if you feel like your timeline is a little bit too tall or too short, again, remember you can just click and drag on this border to make it taller or shorter. Now on our left side, we can simply rotate this view a little bit to pop ourselves outside of the camera and get a bit more of a free view of it. This will help us get a better idea of where this magnet object is within the scene. Let's discuss the plan for our animation before we actually start placing any keyframes. It's important to know what you want to do before you start animating it. Our goal for this animation is to have the spikes start out hidden. Then they'll appear at the top of the orb before traveling down the surface of the orb. Next, they'll submerge themselves into the orb a little bit, leaving only small bumps as they travel across the surface of the orb from left to right. Lastly, the spikes will grow again at the bottom right side of the orb before retracting all the way back into the orb and disappearing. This animation won't be entirely seamless by default, but we'll discuss how to do that near the end of the class. For now, let's begin animating. We're going to start by selecting this empty object, or also known as the magnet. So just make sure you have it selected here in the viewport or from the list on the right side. Now hit Alt and G at the same time on your keyboard to set this magnet back to the home point. This will set it to the origin of the world, which is 0 on the Y, 0 on the X, and also 0 on the Z. This is a useful keybind to remember just to reset an object back to the center of the scene to get it ready for animating. Now let's enable something called a keying set. To do this, we're going to go down here to where it says keying. We'll click on this drop down, and then we're going to go up here to this empty field and click on it. And then we'll choose location found here at the top. This keying set will ensure that when we place a keyframe, we're only placing keyframes on the location parameter, rather than the location, rotation, and scale all at the same time, which it would do by default. This will just help us keep our keyframes as clean as possible. And then lastly, we're going to go down here to the playhead, and we're going to grab this blue icon here and drag it all the way to the left until it hits 0 frame. Now we're ready to begin animating the magnet. We'll start by going up here and switching to our move tool. Then we can grab this Z handle, the blue one, and drag this up until on the right side we'll notice that the spikes disappear completely. You want it to be basically as soon as the spikes disappear, that's where you want to stop the magnet. You don't want to be too far up, as it'll change some of the timing for the animation later on. So move it until it's just outside of the orb here, and if we look over here, we don't see any spikes. Now we're going to hover our mouse over here on the left viewport and hit the I key on our keyboard to place a manual keyframe. To see the values for this keyframe, we can go over here to where we find the Object Properties tab. It's this little orange box. So we can click on this tab, and now we see we have a bunch of values here that are marked in yellow, along with these little diamonds next to them. Any values that we see here in yellow mean that they have a keyframe placed on them. We can also see down here that there's a little yellow dot, it's this little yellow diamond icon, on frame 0. And then lastly, we'll notice that only the location has been keyframed, not the rotation or the scale. And that's thanks to the keying set that we set up earlier, setting it to only keyframe the location. Now let's move down here to our playhead and drag it to frame 30, which is exactly 1 second after the first keyframe. In this left viewport, we're going to grab this blue handle to drag this magnet down, and then we're going to look over here at the right side. And we want to move this magnet down until it's just about to touch the edge of the frame here. So these spikes are just about to make contact. If you're having trouble moving it slowly, you can hold in Shift while you're dragging this thing up and down, and that will slow down the movement so you can be a bit more precise. So we'll move it to about here. That should be fine. So now we can look over here and see that the edge of the frame, which is the edge of what we're actually going to be rendering, these spikes are just shy of it. So now before we place any keyframes here, we'll notice a few different things. Now that we've moved the magnet, we're not quite done yet, and that's because we haven't placed any keyframes. All we've done is actually just move this magnet. We haven't told it to stay there yet. So if we look over here, we can see that these values here are green, and this value here is orange. That means Blender knows that these values haven't changed, because they were 0 before and they still remain 0, but there still isn't a keyframe. However, this orange value here, Blender knows that this value used to be keyframed at a different value, and it still doesn't have a keyframe, so it's essentially a warning for us. So to fix this, we're just going to go over here to the left viewport, and then hit I again to place our manual keyframes, and now we can see that they're all back to being yellow, which means that they have a keyframe on them. We can also see the keyframe down here placed on the timeline. So if we drag our playhead back and forth, we can see that the magnet now moves between frame 0 and frame 30 to the location that we specified. All of the guidance that I'm giving you here for this animation is just that, it's guidance. Feel free to customize your animation, timing, or placement as you see fit. But if you want to have the easiest time while learning, I'd recommend that you at least try to follow along with me. Don't worry about the exact values, just try to match what you're seeing here on screen visually. For our next keyframe, we're going to move our playhead down here to frame 50. Now for this move, we're going to rotate our view just a little bit. And we want to keep in mind that this is the camera in our scene, so this is where we're actually seeing this view from. So keep that in mind as you're moving this magnet around. I'm going to start by hitting G on my keyboard for the quick keybind for movement. And then I'm going to move it down here, lower and then to the left, until it's around here. And then we can move our view up a little bit. And I'm going to move it now towards the camera a little, because I want these spikes to go from the very top of the orb and then start traveling down towards the front side of the orb. So from this top-down view, I can just grab on this little blue square here, or I can hit G again, it doesn't really matter. And we're going to move it over here. And we want this magnet to be just touching the surface here, so we're seeing a little bit of these bumps, but it's not huge spikes poking out. And then feel free to adjust the placement as you like, but you want your spikes, or your bumps in this case, to be roughly about where these are. Once you're happy with the placement of the magnet, just hit I on the left viewport to place your keyframe. Now if we go down to our timeline and drag it back and forth, we'll notice that something interesting happens here. It starts out at 0, the magnet moves down to make some spikes, and then it goes from 30 to 50, and we see these spikes get really huge here right in the middle. And that's because this magnet is actually just traveling in a straight line directly through the center of this orb. So as it goes through the center, if I move down here, right around the middle of this movement, it's really far into the orb, which makes these really huge spikes. That's not really what we wanted to happen. We wanted it to be big spikes that recede into the orb and then start out being small down here around frame 50. It's not necessarily an issue if you like how it looks, but if you wanted to make the spikes a little less extreme, we're going to move here to frame 40, which is right in the center of this movement. And then we're going to move this magnet out of the orb a little bit, trying to keep it roughly in the same spot, but just moving it out of the orb in a diagonal pattern. So we can move it to about here. We want the spikes to still be present, but not huge spikes. So about half the height maybe of what the original spikes were here on the top. And then once we have our spikes here that we like, now we can just hit I on this viewport to place a new keyframe. Now if we go down here and drag our playhead back and forth, we can see the spikes are pretty large. They start getting a little bit smaller, and then they slowly recede until around 50 when they're just these little bumps. All we're really doing with this frame 40 keyframe is just guiding the movement to get a look that we're actually after. We'll be doing this process a few more times during the animation. Now we can head to frame 80. We're going to continue moving this magnet down so that the spikes that we're seeing here appear right around here. We want them to be about the same depth as these, so they're going to be more or less just bumps, and we're looking for them to land right around here on the bottom front side of the orb. So in our left view, I'm just going to rotate around so I have a bit better view. I'll hit G to start moving this magnet. I'm going to move them down. So this might be a two-part movement. So first I'm going to move them down to roughly the right position on the orb. Then I can rotate my view. Again, I'll hit G, and then I'll pull this magnet out of the orb a little bit so these spikes stay smaller. We can position them up a little bit higher until we find a position right around here. Again, once you're happy with what you're seeing over here on the right side, you can just hit I to place your keyframe. You might have guessed already, but we're probably going to have to place a keyframe here in the center. So if we drag back and forth, we can see here that the spikes grow pretty considerably right around this 65 frame mark as they travel to where it is supposed to be here for the 80. I'll leave it up to you if you'd like to fix this issue, but just as a quick example of how I fix mine, we're going to go to frame 65. And again, on our view here, we're just going to move this orb so that it's not so far into the sphere again. So we can hit G, move it out so that these spikes remain pretty small, right around here, and then I'll hit I to place my keyframe. Now I can just drag back and forth and see if it looks like I want it to. And they stay a pretty consistent size, so I'm happy with that. Now let's go to frame 110. And we're going to make the spikes completely disappear before they emerge again right before the end of the animation. And we're going to want the empty object, so the magnet, placed basically right in front of the camera at the lower portion of the orb. So we can do that just from here on the left side. I'm just going to rotate my view, so I'm basically just directly above the orb. And we're going to move it directly in front of the camera, and I only want to move it until it's basically just gone. So if I look on the right side, we can see that these spikes just start disappearing. So right around here. So I have a little bit of a gap here, and the camera is basically right in front of this magnet. If I spin around, you should also have your magnet pretty low below the camera. Once you're happy with what you see over here, we can just hit the I key to place our keyframe. Now we can head to frame 160 over here near the end of the animation. This will be the last keyframe featuring large spikes just before the end of the animation. And we're going to want them to appear down here on the bottom right side, basically in this corner. So in our left viewport, I'm just going to rotate my view around so I'm kind of seeing from where the camera is looking. I'm going to move this off to the right side using G. I can adjust my view from the top, move it a lot closer. We can see here that I'm starting to see spikes. They're a little high, so I'm going to move it down, but first let's get the spikes about as large as we want. So something like that is fine. I'll rotate my view down again. I can pull this down so that the spikes are more popping out the bottom right corner. And this might take a little bit of fiddling with to get it exactly where you want it. And again, you can place these wherever you'd like, but this is where I'll be placing mine for the video. So I think right around here looks good. In this case, I don't mind that these spikes poke outside the frame, as I want these to be relatively extreme. Once you're happy with the placement, you can just hit I to place your keyframe. Now we can drag back and forth between 110 and 160 and see what our spikes do. So we can see here, they go from 80, they're just little bumps, then they disappear, and then they start appearing here and then quickly get really large as they move towards the right side. And then our last keyframe, we're going to move our playhead here to the very end to frame 180. And this last frame's goal is to make the spikes disappear into the orb before the end of the animation. I'd recommend that as you move this magnet to make them disappear, that you actually start moving it towards the back side as well. This will make the spikes disappear as they move around the corner, so to speak, as if they're traveling towards the back side of the orb, and then we just lose sight of them. So on our left side here, this would probably be pretty easy from the top side. So we're going to look at the top of the orb here, hit G, and we're just going to move them out to make them disappear. And then we'll push them back a little bit because we want it to look like the spikes sort of travel out around. So somewhere around here should be fine. And then once you're happy with the placement, just hit I to place your keyframe. Now let's quickly check this movement, just moving between 160 and 180. So we can see here the spikes emerge, they're the largest they're going to be, and then they start receding, and as they recede, they move towards the back side of the orb, as if they're just receding and then going around the orb. Now that we're done with our last keyframe, we can go over here to the play button and see what all this looks like in motion. So we can just hit the play button found here. We can now see the spikes emerge and disappear as they travel across the surface of the orb, giving it an almost living appearance. If there's any timing that seems too fast or too slow to you, feel free to select the keyframes and slide them left or right. This will speed up or slow down the affected movements, based on the distance between the keyframes. More distance between them means that that movement is slower, less distance between them means that movement is faster. I mentioned at the beginning of the lesson that this animation isn't technically seamless. This is due to the moving liquid noise pattern on the surface of the orb not resetting to its original position. You'll notice that right as the animation ends, even though there's no spikes on the orb, we can still see like a distinct pop where the noise pattern resets back to the beginning and then the spikes appear at the top again. This is what's making it not seamless. This isn't necessarily an issue if you don't plan on making an animation that can seamlessly loop on itself. But if that's important to you, we'll need to add more time to the animation so we can return the empty object to the same location it was at frame 0. So if you'd like to make yours seamless, we can go down here and pause the animation. And then we're going to add more time to the end of this so that we have time to move the magnet back to the top before it starts over again. So we'll go down here to where it says end, and we're going to add just one more second. So we're going to set this to 2:10 and then hit enter. Down here at the bottom right, we'll see this scroll bar has a little black dot on it. If we click on this black dot and then drag it over to the right, that'll let us see the rest of the animation. Now we're going to go here and grab our playhead and move it to the very end of the animation, which is frame 2:10. And then over here on the far left, we're going to hover over this gray portion down below the lighter area. We'll click and drag over top of this keyframe here, highlighting it in yellow. Now we can hit Control C to copy this keyframe, and then we'll hit Control and V to paste the keyframe over here on the right side where the playhead is. So all we've done is copied this very first keyframe and pasted it again at the very end. So if we drag back and forth here between frame 180 and 210, we'll notice that the magnet here on our left viewport travels right back up to the very top of the animation so that it's ready to begin again. However, we'll also notice that it's taking a direct path because it's always going to move directly from one place to the other. It doesn't know that we want it to curve around the orb. So to fix this, just like last time, we're going to move to frame 195, which is about right in the center. We can rotate our view a little bit over here so we can get a better view. And we'll just hit G to move this magnet. We're going to move it pretty far outside of this because we really don't want it to get anywhere near this. So somewhere over here is probably fine. Pretty comfortably far away from the orb. Then we can hit I to place our keyframe, then go over here and drag back and forth and just make sure that it doesn't poke into the orb at all. And that's it. We've now made it seamless. So we go down here and play our animation. We'll notice that there's no really noticeable difference between the beginning and the end of the animation. It simply loops on itself and just keeps playing from the end back to the beginning, without the ability to really tell where it's going from the beginning to the end. With our animation finalized, we're just about finished. In the next lesson, we'll render our final animation and discuss the class project. I'll see you there. In this lesson, we'll render our final animation and discuss the class project. Let's begin. This is it. We're ready to render our final animation, so we can share it with all of our friends and family. Luckily, we've been using the Eevee render engine to create this project, so we can expect some really fast render times for the final animation. Before we start the render though, let's add a few compositing effects to improve the look of the render even more. We'll start by heading up here to the compositing workspace. This workspace allows us to add additional post-processing effects on top of our render to add things like glare or lens distortion. The default layout for this workspace isn't super helpful in my opinion, so let's quickly customize it so it fits our needs better. Let's start by going over here and clicking on Use Nodes. Now we can hover over this viewport and hit N to hide the side menu. Now let's move our mouse over here to the top right corner of this viewport until it turns into this little plus sign. Now we can click and drag from this corner and move it over about halfway to make two different viewports. We're going to switch this right viewport by going over here to the top left corner, and then we're going to choose Image Editor. Now let's quickly render a still image so that we have something to look at. Let's drag our playhead to frame 160 down here on the bottom. Then we can go over here to the top left to render, and then choose Render Image. Or you could also just hit F12 on your keyboard. Okay, and just like that, the render is done. However, we can't see it yet, and that's because we need a viewer node. So we're going to go down here to where it says Render Layers, and we're going to hold Control, Shift, and then left click on this Render Layers node. This will use Node Wrangler to create this new viewer node. For now, let's just drag this viewer node over here to the right. We can also drag this composite node over here above it to the right. If you can't see your image like I can here, go up to this backdrop button and then turn it off and then turn it back on again. That should hopefully get your image to show up. Once you can see the image, we're actually going to turn off backdrop for now. So we'll just click this button to hide it. In the right viewport, we can go over here to this small button with the picture on it. We're going to click this drop down and then choose Viewer Node. This will allow us to see our render over here in this image without having to see our nodes sitting on top of it. Before we start adding new nodes to create new effects, let's clean this up a little bit. So we're going to hold down Shift on our keyboard, and then we're going to hold in our right click on our mouse and drag across this line. And we can see when we let go, it makes a new dot here in the middle of the line. Now we can drag from this dot down here to the image socket on the viewer node, and this will allow us to use the same line for both of these nodes. Now on the left side, let's zoom out a little bit. Drag select over all of these, including this dot, so that we move it, and then we're just going to move them over to the right to make some room here in the middle. Okay, so now we're ready to start adding some effects to our image. Let's start by adding some glare to the image, so that the brightest parts of the highlights have some subtle glow around them. In this left viewport here, we're going to hit Shift and A to bring up our Add menu. Then we can click Search, and we're going to type in Glare, G-L-A, and then you can see it here at the very top of the list. We'll choose Glare. Now let's drag this over here to the left side of this line, and then once it's highlighted on top of it, just click to place it, and it'll automatically connect it for us. Now let's zoom into this glare node that we added so we can see it a bit better. Over here on the right side, we can see that this is already making an effect on our image. It's adding these bright hotspots in this shape of the stars across our image. While this is an interesting effect, it's not really the look that we're after. So we're going to change some settings over here to get a better look. First, let's change the mode. So that's up here. Right now it's set to streaks, which is the default. We're going to switch ours instead to fog glow, which is found just below it. We can see now that these stars are gone, and it's replaced by a subtle glow around each of these bright spots, which is a lot more realistic. There's two more settings that we'll change here. So the first is the threshold. If I make this a little bit larger, you can see the word. And then below that is the size. So first, let's just change the size. So if we set this down to 7 just by clicking this little arrow here, we can see here that the glow is just a little bit smaller. If we increase it, the glow goes out further past the highlights, and if we lower it, it gets smaller. The slider for the size only goes as small as 6, and it goes as high as 9. So this is the largest we can make it, and then 6 is the smallest that we can make it. For our project, we're going to set this to 7. Next, we have the threshold found here above it. This is what determines what's bright enough to receive glow. A lower value for the threshold will make more things receive the glow, and a higher value will make less things receive the glow. So things need to be even brighter, so the pixels on this image need to be even brighter in order to receive glow if we increase the threshold. If we lower it, they don't need to be quite as bright in order for Blender to start adding glow on top of them. We're going to make ours just a little bit lower. We're going to set it to just 0.9, hit enter, and it just makes the glow prevalent on a little bit more of these bright surfaces. Next, we're going to add one last compositing effect called lens distortion. So in our left viewport, we're going to zoom out a little bit so that we can see the gap between these two. Then we can hit Shift and A to bring up the add, go to search, then we'll type in lens, L-E-N, and then we can choose lens distortion. Again, we're going to drag this between the glare and the end here, and just place it on this line and click to have it automatically connect. Now let's zoom into this node, and this new lens distortion node allows us to do just that, distort the lens. So if I make this node just a little bit wider, we can see the sliders here at the bottom. We have distortion and we have dispersion. Dispersion is typically what you'll be using when you add this node, but we'll go through both of them first. So distortion, if we increase or lower this, we'll see that it's changing the distortion of the lens. So a higher value will make it more spherical, and then a lower value will distort the middle so the middle is smaller than the outside. These negative values here mimic something similar to a rectilinear lens, and then these positive values mimic something more similar to a fisheye lens. We won't be using any of the distortion for this image, so we're just going to set this back to 0. We will, however, be using dispersion found here below. Let's go down here and set our dispersion to 0.05 and then hit enter. So we'll notice that our image moved just a little bit, and it also seems to zoom in a little bit. This dispersion value, though, is mostly found here along the edges of the frame. So if we zoom in on this image, we'll notice down here that we're starting to see a bit of a rainbow fringe around the edges of our object. And the closer we get to the corners, the more obvious it is. So it's pretty obvious here, whereas if we move closer here, we can barely see it. And that's because this dispersion effect primarily affects just the edges of the image, and it leaves the center untouched. If we increase the value higher, so if we turn it up really high, something to say 1, we'll notice that it does come along with some distortion, such as the slider above it, but it's primarily adding all of this rainbow effect we're seeing. But if we zoom into the very center of the image here, we're not really seeing any of that rainbow effect. And that's because even at these really high values, you still only get it along the edge. Now obviously this is pretty high, and we don't really need this much dispersion for our image. So we're going to set it back down to 0.05 and then hit enter. This small amount of dispersion that we're seeing here along the edges makes it look similar to something like chromatic aberration, which is something you find on actual camera lenses. So while it's essentially making the image imperfect, it is actually a little bit more realistic to have a tiny bit of dispersion found along the edges of your image. In our case, I also think it just kind of looks cool having this rainbow blur at the edge. And that's it. That's all the compositing effects that we're going to add. So we're ready to finalize our animation for the final render. All we really need to do is set up an output location and an output file type. So let's do that now. We're going to go over here to the rendering workspace found directly next to the compositing workspace. You'll notice that this image here in the center looks like our render, but it's missing all of the effects that we added. And that's because we added them after we rendered our image. So if we simply render our image again by going up to File, Render Image, we'll now see all these effects that we added are applied on the image. Now let's adjust the output properties. We can find those over here with this little printer printing out a photo. So we'll click on this tab. We're going to go all the way down here to the output settings found at the bottom. And then first we need to set a location for our animation to save when it's finished rendering. We'll do this by going over here and clicking on this little white folder icon. And then you'll need to navigate to a location on your computer that you'd like to save this video file. I'd recommend that you save it in the same place as the Blender file if you're unsure where to choose. Lastly, we need to go down here and choose a name for our animation. I'm going to name mine Ferrofluid _animation _01, and then lastly I'll end it with another underscore. So I'm going to put one more underscore at the end of the name. The underscore at the end of the name is important as it provides a space between the name and the automatic numbering that Blender places after the file name. Without the underscore, the automatic frame numbers that Blender places at the end of the file name would run right into the version number that we added here, being 01. So this underscore just adds a little bit of a space between those so they don't run together. With our name finished, we can just choose Accept down here at the bottom right. Now we need to change the file type this animation will be saved as. So over here on the right side, we're going to choose File Format, and we're going to change it from PNG to FFmpeg video instead. Now we'll go down here to Encoding, twirl this open, and then for the container, we're going to choose MPEG-4 instead. which is just an MP4 video file, which is a very universal file type. And then lastly, we'll go down here to output quality, and we'll change it from medium to perceptually lossless. This will ensure that we don't have too much compression on our image. With all of these settings, we've told Blender to create an MP4 video file with the quality turned up slightly so that we get a minimal compression on our video. And that's it. We're ready to render our animation. To do this, we're going to go up here to render, and then we're going to choose render animation instead. Or you can hit Ctrl and F12 at the same time if you'd prefer. This will begin rendering your animations starting from frame 1, so you don't have to worry about setting the playhead there at the beginning. It's going to do that automatically. Also, don't worry if it seems like the compositing effects that we added aren't being shown on each frame. Blender sometimes skips the visuals for these as it renders, but it will still show in the final video. This should only take a few minutes to render, so I'll see you in just a moment when mine is finished. I recommend you pause the video until your render finishes as well. I'll see you in just a moment. Alright, my animation is finished and it looks great. It only took my computer a few minutes to complete this animation, so hopefully yours wasn't too much slower. Now that the animation from class is complete, what can we do to customize it for our class project? There's a few simple changes we can do to give your animation a unique look. Let's go over some of these simple changes we can make now. First, before we make any adjustments to this file, let's save a new version that we can play around in without affecting the original. To do this, we're going to go over here to File, and then first we're going to save our file as is. So make sure that you save the file first so you can save the original as it is now. And now we're going to go back to File again, and this time we'll choose Save As instead. Now we can go down here to the name. We're going to click on the front of this name. We're going to type the word Class Project, and then add an underscore to put a space between them. This will give our file a brand new name, and then use the original file as the base. Now we can go over here and choose Save As, and there we go. Now we're inside the new Class Project version of this file, and our original is saved and safe somewhere else. With our new version saved, we're ready to begin customizing. The easiest change is simply changing the color of the Ferrofluid. Let's head back over here to the layout workspace where we were working before. Now we're going to switch this left viewport back to the shader editor. So we can do that by using this dropdown and then choosing shader editor. In our right viewport, we're going to select the orb here in the center so that we can see the material. We're going to zoom out a bit so we can see the principled BSDF, this large green node here. We'll also need to make sure that we can actually see the material here on the right side. So at the top right, we're going to switch this to the rendered view. And we can do that just by clicking this button here on the far right. Changing the color of our Ferrofluid material is as simple as just changing this base color found here. So if we click on this color box next to base color, we can use this color picker and just choose any color we'd like. So you'll move it to somewhere on this circle here to choose the color. And then on the right side, we can drag this up so that the color is a lot brighter. So maybe I'll make mine a really bright red in this case. Feel free to change the color of your material to whatever you'd like. We can also change things like the roughness for the material. So if we zoom in here to get a bit better look, we can drag this roughness slider up to make the material a little bit less mirror-like. So if we want it to be a bit more blurry, we can make it really high. Or if we still want it to look a little bit metallic, we can move it to around here, maybe 0.3 in this case. Another change that's relatively easy is adjusting the HDRI. That's what's controlling the lighting for our render. So in our shader editor over here, we can go up to Object at the top left, and we're going to switch it to World, which is where we set up our HDRI image to begin with. Now we can click on this white folder icon on this interior.exr node, which this is actually the file name for this file. So we can go over here and click on this white folder to open it. Then we have all of these different options that we didn't choose before. In this case, I'm going to choose maybe the sunrise image here, and then hit open. Now we can see on my render on the right side that a new HDRI can really change the mood of the image. We can also use this Z rotation found here to adjust the rotation of this HDRI to change the lighting. I think in my case for this HDRI, somewhere around 300 for the Z looks correct. We're getting some nice highlights here. We have a relatively unintrusive background, and everything generally looks pretty cool. If you don't like any of the options that you have already downloaded, and you want a completely new HDRI, such as the one that you saw for the intro video in this class, you can find them free at the website Polyhaven. There are a ton of different options here, and I'm sure you'll find something that you like. So you would simply just choose the HDRI that you like, then you can go over here and download it. That'll give you a file that you can use in that open menu inside Blender, and then choose that as your HDRI. I recommend you save this new HDRI along with your Blender file and the animation that we rendered out. Depending on the HDRI that you use, you might want to add a little bit of depth of field to your camera. The HDRI images included with Blender are relatively low resolution, so they can appear kind of pixelated at certain angles. So we can see here if I zoom in, it's pretty obvious that this is a low resolution image. The depth of field that we add will apply a soft blur to the background to obscure this pixelization. So let's zoom out here so I can see my whole image. Then we can go over here to the top right, and we're going to choose our camera. Now we'll go down here to the Object Properties tab, which is this little camera icon in green. Then we can turn on depth of field by checking this box, and then twirl it open so that we see the options. For our purposes, we can just use the Focus on Object setting. So we'll click on this eyedropper here at the top. Then we can click on this sphere, and that will make it the focus object. So Blender will use this camera to do its best to focus on this object in terms of its distance. This will lock the focal distance to the center of the orb, which works perfectly fine for us. And then lastly, we'll go down here to the f-stop values. So lower numbers will make the background blurrier, and higher numbers will make it less blurry. So for our purposes, we'll set it to 1 and see what that looks like. So now if we zoom in on the background here, it just has a soft blur over top of it, and you can't tell that it's pixelated. But our orb here in the center is still relatively sharp. If you wanted it even blurrier, you could set it to something like 0.5, but then you'll notice that your orb is actually starting to get a little bit blurry as well. So I would recommend something around 1, but it's free for you to choose. And if you didn't like quite how blurry this is, you could set it to a higher value like 1.5, and that will make the background just a little bit less blurry. The last obvious change I'll be explaining for this lesson is the animation. This render is largely about the animation of the spikes, so if we make any changes to this animation, it will make a noticeable difference in the final video. I won't be walking you through how to customize this entire animation, but let's walk through just a few things that will be useful when customizing your own. Firstly, how do we update the value of a keyframe? This will let us keep the keyframe at the exact same place on the timeline while updating the position of the empty object. So first we'll need to select the empty object, which in this case is the magnet for our scene. Then on the left side, we're going to switch this back to the 3D viewport. Also, after you're done adjusting your HDRI, you might want to switch this back to the object. That way you can adjust the material for the object and not be adjusting just the world settings. So again, we'll go up here to the top left. We're going to switch this to 3D viewport. And now let's go down here on our timeline to a keyframe that we'd like to update. So in this case, just for the sake of example, we're going to go to frame 65. And then here in our left viewport, I'm just going to move this magnet object a bit closer to the orb so that the spikes are even larger. Now in this left viewport, we're just going to hit I to place our keyframe, and that's going to overwrite the original keyframe that was there. If we go over here to our object settings, so if we go over here to our object properties, we can see here that the keyframe has been placed because these are all yellow, and it's using these new values that we moved. So now we can zoom our view out a bit so we can see the full animation. So if we go down here and drag our playhead back and forth to see our animation, we can see that the subtle spike that used to be here at frame 65 is now a much larger spike. So we've completely updated this keyframe to change the animation. The last thing I'll show you is how to retime the animation by moving and scaling keyframes. This will let us keep the overall animation the same, but allow us to make certain movements faster or slower based on where the keyframes are on the timeline. The easiest way to retime an animation is to simply just drag around the keyframes. So if maybe in the beginning of the animation, we want these spikes to appear much faster than they are now, instead of taking a full second, maybe we want them to only take a half second, we would just drag select over this keyframe here, turning it yellow to let us know it's selected. And then we can click and drag it and move it over here to frame 15. So now if we drag our playhead back and forth, we can see that it now only takes a half second for these spikes to appear, and then they stick around for a little bit longer because we've changed the timing between these two as well. You can also click and drag over groups of keyframes. So maybe we drag over all 3 of these, and we can reposition these as a group. So we can move these all to the left as well. If we move our keyframes to the left, it'll make them happen sooner in the animation. And if we drag them to the right, it'll make them happen later. If we move keyframes closer to each other, such as moving 30 and 40 closer to each other by 5 frames, it'll make this whole action here much faster because there's less time for it to happen. If we instead drag them apart, it'll make this action a little bit slower because there's more time for this movement to happen. One important thing about moving keyframes though is you don't want keyframes to cross over top of each other. So if I grab this keyframe here, currently at frame 46, and I drag it past this keyframe, now I've reordered what's happening. So this action here now happens after this action, when before it used to happen before. So we can see here, this really changes the way it's working. So it's moving backwards now because I've reordered these actions. So that's something to keep in mind when you're retiming and reordering these keyframes. Another option for retiming is to scale an entire group of keyframes. This will allow us to scale the distance between a group of keyframes uniformly. By scaling them, we're not only changing their positions on the timeline, but we're also changing how quickly the animation plays these movements. So as an example, we'll drag select over frame 160 all the way to frame 210. So we'll highlight all 4 of these keyframes. Now let's drag our playhead over to frame 210 and place it here at the end. Now while hovering over the bottom, we'll hit S on our keyboard for scale, and then we can start scaling these keyframes and moving them further apart, or we can make them happen much sooner. So in this case, let's make this happen a little bit slower. So we're going to scale it until the last keyframe ends right here around 130. We've now made this entire portion of this animation occur much slower, so it takes longer for these actions to occur. One important note about scaling keyframes is they always scale from the location of your playhead. So if I put my playhead here at 130 instead of at the end, and I hit S, we'll notice that they're now scaling from 130 rather than from the end of the animation. This is important to remember when you're scaling, that way you don't accidentally move something further than you thought you would. So if I put it here, we can see here that it's moving these keyframes from the center of the playhead. And with that last change made, we've reached the end of this lesson. These are by no means the only changes that you can make to this animation, but this should set you up to make some really cool looking class projects. If you're looking for more things to change, try adjusting things like the Voronoi texture in the shader editor to change the look of the spikes, or apply this material to a different shape. I can't wait to see what you all come up with for your class projects. I'd highly recommend you convert the final video into an animated GIF so it's easier to share on platforms like Skillshare. You can find a full tutorial on how to turn this into an animated GIF in lesson 16 of my Cartoon Bumblebee animation class. If you'd prefer to figure it out on your own, I'd recommend the free website easygif.com/maker. Good luck with your animated GIFs. In the next lesson, we'll end the class with some conclusions and farewells. I'll see you there. Congratulations on reaching the end of our class. I wanted to take a moment to thank each and every one of you for taking my class. Your participation and excitement for learning is incredibly rewarding for me as a teacher, and I can't thank you enough. I hope you've had fun learning how to create a simple and animatable Ferrofluid material in Blender. It's been a pleasure guiding you, and I hope you found the experience both fun and valuable. Now that you got these awesome skills under your belt, I can't wait to see where your creativity takes you. I wish you the best of luck in creating your own awesome animations in Blender. Feel free to tag me on Instagram with your creations. I'd love to see them. You can find me as @HarryHelps_ on Instagram. As I mentioned at the beginning of this class, this entire class is on Skillshare, where I'm recognized as a top teacher. You can find this class alongside over 20 more premium classes, the vast majority of which are Blender classes. Each of these classes follow an identical beginner-friendly approach, and a lot of them include starter files to make the class even more guided. I've included a link for a free month of premium Skillshare membership in the description and comments below. During that free month, you can watch as many classes as you like across the entire platform, featuring thousands of interesting topics. I've even received 4 different staff picks and over a dozen features from my classes, like Complete Beginner's Guide to Blender 3D, Learn the Basics of Character and Object Animation, Create a Retro Anime Illustration in Blender, and Create a 3D Vaporwave Animation. If you're not interested in joining Skillshare at this time, no problem. I'd really appreciate it though if you subscribe, like, and share this class though. It really helps out my channel and allows me to bring more free classes to you. If you're looking for another completely free class from me, you can check out my YouTube channel. There you'll find a class about modeling and animating a magical portal completely from scratch. Thanks again for watching my class, and I hope to see you in another one soon.